We're now going to begin our examination of the BardWords case study. This case study will show how Java's object-oriented features can be applied to a program that searches the complete works of Shakespeare for given words and phrases. We call this program BardWords since William Shakespeare was known as the Bard of Avon. We'll begin by giving an overview of the analyzer portion of the BardWords case study. The BardWords class uses various components from the Java class library, which is a set of dynamically loadable libraries that the Java execution environment can call at runtime. One of the Java class library components used by BardWords is breakIterator, which provides methods for finding the locations of boundaries in text. The BardWords class also uses the regex package, which provides classes for matching character sequences against patterns specified by regular expressions. A regular expression in Java is a sequence of characters that defines a search pattern and can be used to match and manipulate strings based on the pattern. Here's some example output from applying these Java object-oriented components to the BardWords program. This program searches the complete works of William Shakespeare for lines matching the regular expression Lord, followed at some point by true or false. In this regular expression, the \b is a word boundary anchor that matches the position between a word character and a non-word character, or the beginning or end of a string. We use \b to ensure that Lord is matched as a whole word and not as part of a larger word. Likewise, we also use \b to ensure that true and false are matched as whole words rather than part of larger words, like truly or falsely. In addition, the regular expression is used to match any character, except new lines, 0 or more times, thereby allowing any number of characters to appear after the word Lord, but before true or false. Finally, we use the regular expression grouping construct to group together two alternatives separated by the pipe symbol, which will match either the word true or the word false as whole words. Given that regular expression and the complete works of Shakespeare, here's the output that comes from searching the works of Shakespeare to find all matches of this pattern. You can see that we get regular expression matches from the tragedy of Hamlet, the tragedy of Julius Caesar, the tragedy of King Lear, and so on. Now that we've given a quick overview of some of the object-oriented class library components that are applied in the analyzer portion of the BardWords case study, let's take a closer look at the structure and functionality of the BardWords class. To start with, this class defines fields that store the file name containing the works of Shakespeare and the list of phrases to search for in these works. Let's now take a look at those fields in the BardWords class. The Shakespeare data file string stores the name of the file containing all the complete works of William Shakespeare, which can be obtained from the link at the bottom of this slide. The phrases field is a list of phrases to search for in the works of Shakespeare. This field parameterizes the list interface with the simple entry type, which contains a key and a value, storing a word to search for and a regular expression to compile. For example, the word could be Lord, and the regular expression could be the regular expression we looked at earlier that finds any place in Shakespeare that has Lord followed by true or false. We'll walk through the implementation of makePhraseList, which is a factor method that creates the list of Bard phrases, in part 3 of this lesson. The BardWords class also defines methods that structure the overall flow of control through the program. We'll take a look at the main and process BardWorks methods now. As usual, main provides the main entry point into the program. The first thing that happens in main is that the testDataFactory_getInput method is called to read a file containing the works of Shakespeare and to create a list of string objects, one work per string. We'll walk through the implementation of the testDataFactory_getInput method in part 3 of this lesson. Next, the Java for each loop is used to process the list of phrases to see where they occur in the works of Shakespeare. We'll now take a look at the process BardWorks method, which uses a regular expression to search the Bard works, in other words, the list of strings containing the works of Shakespeare, for matches of that regular expression. The first thing the process BardWorks method does is initialize a local variable called BardWorks matching word, which will be a list of Shakespeare works that will contain the word that's passed as a parameter. Next, we use a Java for each loop to loop through each work in the BardWorks and add a work to the list if and only if it contains the word word. And you can see we're going to call the findMatch method in order to do this. We'll walk through the implementation of the findMatch method in the next part of this lesson. Process BardWorks then compiles the regular expression passed as a parameter in order to perform case-insensitive matches. The case-insensitive flag passed to compile instructs this method to ignore case when performing the regular expression pattern matching. For example, the word Lord with only an uppercase L, Lord with all lowercase letters, and Lord with all uppercase letters will all match when the case-insensitive flag is passed in to the pattern compile method. Finally, the show regex matches method is called to display the portions of the works of Shakespeare that happen to match this pattern. We'll also walk through the implementation of this method in part 2 of this lesson. So that's the end of part 1 of our overview of the Java object-oriented BardWords case study.